My name is Kelly O'Brien. I'm a research fellow at West Virginia University, and I'm going to pass the microphone over here pretty quickly to the folks from the Manchester Craftsmen Guild who are going to explain their program and do a demonstration. If you would, silence your cell phone. And just to let you know, the last thing happening in this room today will be 4 o'clock with Brian Seabaz, who will be running his ceramic extrusion printers. So now I'll turn the microphone over to Dave from Manchester Craftsmen Guild.
Oh, thank you very much. I think I have a mic on. So if you
do.
Yeah, excellent. All right, test. All right. So I'm Dave Diley, and I'm from the Manchester Craftsmen Guild. So shortly I'm going to explain what is the Manchester Craftsmen Guild, but first I just wanted to thank everyone, for putting this together, and thank the 92nd Street Y, for this awesome opportunity, and for streaming this today. So where we kind of come into this technology piece, it starts actually with a program in Pittsburgh, Pennsylvania that was founded in 1968, where one man, Bill Strickland, started to do ceramics with high school age students in a little row house in his neighborhood. And what that evolved to over more than a decade is it became an art center that was built in Pittsburgh to give high school age students, 9th through 12th grade, opportunities in the visual arts in the after school time. And the artists that teach the students are beyond, the relationship is beyond teacher and student. It really is mentor. It's a mentorship program to give students opportunities that they may not find in their traditional schools. So our studio has become more of like a college level experience for children down all the way to the ages of, 6th grade. So we teach photography, ceramics, the digital arts, and design arts. And where this technology piece comes in is most recently we've opened something we're calling the Tech Suite, so that's what you see over here. And we're doing laser cutting and 3D printing with the students. So with our history, with our 40 years of history of doing programming in traditional mediums such as printmaking, painting, drawing, and ceramics, it's really interesting for us to embrace this technology and kind of build the bridges between how they intersect. So when we set off on this mission to engage the technology, we did our research. So we went out and we wanted to see what was being done in the fields. So we went to MIT, to their media lab. Hugely interesting. Lots of wild stuff going on in there. If you ever get a chance, I'd say you should definitely go there and visit and go for a tour. What we found in this engagement was that accessibility is a high point for us at Manchester. We wanted to make sure that the technologies we're sharing with these students would be accessible. So it's not just enough to be cutting edge, bleeding edge, wow, we're doing the most amazing things. This piece of equipment cost $2 million. That's great, and that does happen at the Media Lab, but I think that's a different realm. In the high school education realm, we wanted to make sure what we were embracing and what we're offering to these students was something they could find when they walked out the door of our place and went into industry, into higher education. So whether it be in the job place or an internship, they're empowered with what happens at Manchester to take that immediately out into the real world in a realistic framework. So what we found, my thing's over here now. I'll kind of go through this list because I know we only have 30 minutes, so real quick. We also went to something called Create Lab, and that's in Carnegie Mellon University, and they have a lot of wonderful programs there, embracing technology. I'd say just go to their website to find out more. It's wonderful. We also went to many different high school programs, both locally and nationally, to figure out what's some of the best practices that are being done. What kind of equipment are you using? What's the curriculums look like? What are some of the outcomes? So this is another example of a local school district in Pittsburgh. And we were really happy to have the opportunity to go to Minnesota, to Montemedi High School. Their program had been identified as the first high school program that embraced the Fab Lab model. So MIT's, they have a traditional formal model for Fab Labs, and this was the first high school in the nation to have it in a high school realm. So we went there, and quickly we could see, you've done this model for a decade. what are your outcomes? What were your successes? What are the failures? What are the challenges? And through that, we identified that that didn't fit. That wasn't a perfect fit for what we were going to do at Manchester. So we learned a lot. And we also, in our research and development phase, went to visit industry leaders in these fields. So while we were in Minnesota, we went to something called Stratasys. They're one of the largest manufacturers of 3D printing machines globally, as well as we went locally to something called X1, and it's in Irwin, Pennsylvania, only about 30 minutes from where we're located. And they're also a leader in industrial 3D printing, and their mediums reach out beyond plastics and some of the common materials all the way into various metals and glass 3D printing. And this is at a very high level. You can see these are some examples of the objects coming off, and you can see the detail. Like these type of objects, and as Andy said earlier, and if you've been through some of these lectures, 3D isn't the solution to everything, but it definitely is a solution to some things that CNC machining, you can't achieve that. Even through lost wax casting, you can't achieve some of these outcomes. So for specific outcomes, it's sometimes the only answer. So this is very exciting that we have access to this. So here's Jill, myself, and we're on a field trip at X1. So it's really important as part of our educational platform, again, as I said, to empower these kids to walk out our door into the industrial realm or into higher education. They get real world access to these things. So we go on field trips with the kids. Their programming that they learned in our classroom, we just emailed it over to X1. At the end of the tour, they're flipping screens on me, so I keep it. At the end of this tour, we go into the boardroom, and the students' objects they made are cast in metal through their process with their machines. So really, to the word of what we said, it just translated right over into industry beautifully. So in making a program, obviously, we got to touch all our bases. So through our research, we were able to define what is the best processes, what is the best equipment, what makes the most sense for what our outcomes are. And we know we have a framework. We know that we're going to be teaching 10-week courses, and the students are going to come 1 day a week. We're going to be working with a process that sometimes takes 49 hours to print one object. So we did our homework, and what we came to the conclusion of is that we're going to need many pieces of this equipment to be able to execute outcomes for a group of 16 students every 10 weeks. So we did acquire many printers then. Talking about the curriculum component though, so I'm going to shift gears for 1 second. We worked along with industry experts, so we both consulted with a curriculum expert as well as another local nonprofit in Pittsburgh called the Additive Project. And it was a really nice marriage, but the goals of the Additive is to really take these courses, take this curriculum, and make it available globally through an online access. So this, some of the things that we've learned through this process, they're accessible to everyone, to all of you, through going to the Additive Project's website. So just keep that in mind. And this is just a picture of our curriculum expert, Dr. Jerry Thompson, and we're really excited and proud to work with her because what she has allowed us to do is take something that on the surface, if you came to our classroom or if you asked our students, they would probably describe the engagements that we have as informal. They may not even know there's a lesson plan for that day, that we have specific curriculum, that there's a underlying documentation to everything, because it's more about getting them in there, getting their hands on the process and that tactile learning. But the truth is that we do our homework behind the scenes, and it's people like this that make us, parallel what's happening in both traditional school. So the validity is there, which is very important when you're trying to generate support financially, to be able to say, what is the rigor of this? Well, it's all here and documented for you. But truly, here's the outcome, and we do it in this very non-traditional fashion. So I'd love to get into all that, but I just want to focus on the technology for now, but it's very exciting. The Manchester Craftsmen's Guild model, that's what it's all about, is mentorship through the arts. So next slide. So we got to the point where we did our research and we're like, we know a little bit. We knew a lot more than when we started, but we're about 10% probably at that point. So we designed our space. So this is the space that we sketched up. This is good. It's like exercise. If I eat a heavy lunch, so I got to keep moving. But so this is the space that was designed. And what this entailed, though, it looks nice on paper, but it was really like giant concrete saws in the building, slicing things, and sledgehammers swinging. And when that was going on, I tell you, I was like, if this goes wrong, I just might not be here very much longer. When they start cutting with masonry saws inside the building, yeah, you think this is real. It's real. So this is the design. And this is the reality. So it happened, I'd say they did a pretty darn good job of going from the sketch to reality. So it's, and again, this is Bill Strickland's idea of what high school looks like. This room is an example of that. And our building's an example of that. Our ceramic studio is an example of that. This is a handmade, beautiful piece of art furniture made by a student of George Nakashima, Tadao Aramoto. It was in the original plans, and I know you can appreciate this if you work in nonprofit realms. This was in our original proposal to say, Mr. Foundation, please, we're proposing a beautiful environment can create beautiful people. And a beautiful environment, in our definition, has handmade art furniture for high school kids. And here it is. And again, what you can't see in this photo, which we might see as we move, though, is there also a knee wall cap that's made by him as well, and whoever that guy is. This is when we actually had it completed, and we're getting ready for our. We were doing a ribbon cutting ceremony, so this was very recently, and it was the amount of work that goes into these type of projects. It's really wonderful to be able to finally let go and release it over to the kids, access, and get them true access to all this stuff. So that's what you're seeing here. So again,
you want me to?
Yeah. Well, I'll let Jill talk a little bit. I mean, I like to hear myself, but I'll turn it over to her. So.
Well, we can just bounce back and forth a little. Can you hear me okay? Okay, good. So I'm Jill, and I am not a ceramic artist. I'm a digital artist. And also 2 years ago, I had no clue how to model in 3D. I knew nothing about it, and I ended up kind of leading up our courses and our purchasing of equipment, which was a little intimidating, but I just want to share some things that happened along the way in case you guys are thinking about doing something like this, thinking about buying a 3D printer. I'm going to tell you a little bit of what our experience was like. So this is the very first printer we bought. It's the MakerBot Z18. We bought it. We bought two of them like weeks after they came out, like right after it was put on the market. Bad idea. If you're ever going to buy a 3D printer, don't buy it right as soon as it comes on the market, because there's going to be a shitload of bugs, and there was. And so I really hated them for a long time. The extruders kept clogging. So the original extruder is on the left. They call them smart extruders. Well, they were really dumb when they started, but they since have modified and developed new extruders, which are working great. And so now they're working perfect. I mean, they're like two of the most reliable printers we have. So Z18s, we're good with those. We also, the next thing we purchased was a Uprint SE Plus. This is made by Stratasys. This is the Cadillac that we own, or the Rolls Royce maybe, like a $22,000 printer. But it's one of those printers that you can start and you can just walk away, and you don't have to worry about it. Huh? They work. Yeah, you just don't have to worry. You're not going to come back and see a pile of spaghetti. And that happens on a lot of printers until you get them tweaked right. So these also, they print in ABS plastic, and then there's a bath. The unit on the left is a bath to put the model in to dissolve away support material. There's support material. Anytime you have more than a 45-degree angle in a model, it needs supports underneath it to hold it up. Okay, so the support material dissolves away, so you have really smooth models. And there's a couple over there that were printed on the Uprint, and they're so soft and smooth, and they just feel so nice. So, and the other printers, like, I see there's an M2 over there printing. Am I right? Is that an M2? Yeah, I love those things. They have breakaway supports, and they break away pretty good. So there's two different types of support media, the kind that dissolves and the kind that breaks away. We also purchased a laser engraver, and as you can see, we're not the only ones who laser engraved our names on plates. Seems like everybody did. But the laser engraver has been awesome. We actually are marrying 3D modeling with laser engraving. So we'll take a 3D model and we'll put it in Autodesk program called 123D Make? Yeah, 123D Make. And it will slice the model however you tell it. It can be slices like this. It can be radial slices around. It can be just interlocking slices. And then we just take cardboard, put it in the laser engraver, and the program will cut out all the pieces to make the 3D model. And you'll see them at the end. I've got some pictures. But yeah, we've been, yeah.
I think it's falling inside.
Whoops.
Can't see it there. There we go.
Okay. So the Maker Gear M2s, we love them. And we found out about them. Was that at Mata Media? Did they have them there? Yeah. Yeah, and they're really nice printers. They're so open and they're so easy to work on. And by the way, if you're going to buy a 3D printer, you're going to have to work on it. You're going to have to learn how to fix it and repair it, and it's just part of it. Tech support is typically forums online. You can't talk to a person generally unless you pay a lot of money. So just be ready if you decide to get a 3D printer to learn a lot about it, watch a lot of YouTube videos and fix them when things go wrong. So yeah, we diversified a lot. We bought 2 Maker Gears and 2 Print Arbots, and we haven't been successful with 2-color prints yet. They're a real pain to get both of the nozzles so that they're level and so that they're laying down filament the way they're supposed to. I mean, you can get one to work fine, and then, yeah, it's just very difficult to do dual extrusion for 2-color prints. And the Ultimakers, of course, are really user-friendly. That's why they're here. That's why I take it with me everywhere. That's my choice printer to bring to conferences or whatever. The Ultimakers are really, really user-friendly. I did have some issues with them. You have to make sure that you keep like dusty stuff away from them. When Tadao was putting the end caps in and installing the table and sanding, both the Ultimakers went down like right away because dust got in the filament tube, and it was coming up. And the extruders, the nozzles are so tiny that a little piece of dust is going to cause you a problem. And so we had major issues with that. I see that this, I believe this is the same printer that's running over there. We bought it because it's a dual extrusion printer. We wanted to do 2-color prints. It's really been a nightmare. I haven't been very fond of this, but even MakerBot puts on, this is what they have on their website. With an advanced desktop 3D printer and experimental dual extrusion. And it really is. It doesn't work all the time. Designed for trailblazers and 3D printing experts. So, I should have read closer, or they've added this since. I don't know. But yeah, this printer's been a hard one to keep running. We can print with 1 color. Printing with 2 just hasn't been best for us. So then we wanted to get into scanning. And the first scanner we tried out was, I don't know if you guys are familiar, this is an Xbox scanner. It's a thing that watches you when you're playing games that, tracks all your movements. But they have the Connect for Windows. It's just like the same thing, basically. And we had a lot of trouble. We paid for software to use it, and I had major issues like tracking and getting it to work. And so this is what we finally ended up with, was an iPad with the structure sensor, and this is awesome. This is really awesome. As a matter of fact, we scanned Brooks in, Brooks Oliver. I don't know if you guys can see it. Here he is. He's over there. So anyhow, we scanned him in. It works great. You just have to, chop off the bottom or whatever and clean it up a bit. But this scanner works so good. So I highly recommend it if you want to try working with scanning, 3D scanning. How much was it? Like 300? The scanner was like
affordable, yep.
300. Yeah, and then iPad Air was maybe 5 or something. So this is what I would recommend if you want to do some 3D scanning. And if you want to be scanned, I'll scan you in after. You know, I can email it to you. So yeah, the next thing we had to do was figure out our software, and the additive project was really helpful. They're totally into freeware. You know, there's so much freeware out there, and so everything we use, the kids can download at home for free. And so for solid modeling, we use Autodesk's 123D design. So solid modeling is just taking things like spheres and cubes and cylinders, and you just begin to add them together or subtract them from each other, push, pull. There's all kinds of things you can do, but it's more of a geometric program. And then we use Sculptress for mesh modeling, which is more like when you open Sculptress, you have a ball in the middle of the screen. And it's kind of like working with clay. And you can turn on symmetry so that if you draw an ear here, you get one over here. And so it's pretty cool. And this is all freeware. And then, I don't know if you guys were here this morning for that one presentation. What was the guy's name who was showing the software that he wrote?
Was it Andy Brayman?
Andy, yeah. So he was talking about parametric software. Well, his looked a little crazy to me, personally. This is really simple. This is really simple. That is really simple. So it's a website. You just go to shapeshifter.io. And you choose a template to start with, and there's probably a dozen. And then from there, you just tweak the parameters on the right, the sliders, and you can come up with some really amazing pieces, and it's really fun to work with. It's simple. Kids love it. Adults love it too. So, yeah, and we've done some presentations. Our kids have actually exhibited their 3D models. This is a gallery in downtown Pittsburgh that we showed some of their models. And these are the marriage of 3D modeling and laser engraving. These are the cardboard models that they built that were cut out on the laser engraver. We also do jewelry. And these are all done on the laser engravers. These were all cut out. The Steeler emblems, it was acrylic. They cut out acrylic. And the charm bracelet, those are little acrylic charms. And then the earrings are wood. I think that's it. Do you have anything else to add, Dave?
Well, it's been an exciting trip, that's for sure. And I think we're probably a good example of kind of starting from ground zero with this, and really kind of taking a history, like I said, of traditional arts, photography. We still are doing photography in the chemical-based realm. So we have a beautiful dark room we're working with high school age kids in, and we also have a digital dark room, of course, to empower them to have the standards of today. But I think coming out of ceramics and photography, traditional printmaking processes, painting, drawing, and then really embracing this technology and seeing the kids' enthusiasm and their creative imagination and how they're making the connections with this new technology. It's pretty exciting because I think it keeps me young and keeps me excited, because I feel like I get limited, just as everyone does, because you can get overwhelmed quickly with so many things in life, especially technology. It seems like it's moving at a very rapid pace, and many of these these programs and things, they seem like a world in there of their own. It's like entering a library with 1,000 books and thinking, which one do I grab first? But I think in working through this, it's taught me that, working along with the kids and seeing their growth and kind of their first engagements, I think that accessibility, again, is kind of a high point. And that's, if there's anything to take away, I think, from what we're bringing, is that we're pretty young in this. We started about a year and a half or maybe 2 years ago with this concept, and now we've arrived at this wonderful opportunity to have equipment to share with all the youth of the Pittsburgh and its surrounding area. But I'd say that we're learning. We're kind of learning right alongside them, and it's really an exciting time. And I know a lot of people have an anxiousness, I think, in doing new things and trying new things. And I think that what I feel is this is only complementary. It's not really replacing any of these core foundational arts that we do, all the hands-on, the tactile. This is something that just can become another tool, as I think that's been kind of a theme for today, is a digital tool, and how can this help us, serve us, or just complement what we're excited about. So.
Yeah, one thing I forgot to mention was the fact that Brooks Oliver came to MCG as a visiting artist, and he worked with our students. Yeah, and we have some of the pieces that were made in that workshop. He worked in the tech suite. They developed cookie cutters and sprig molds and things like that, tools to take into ceramics. And that's what we've got over there, some examples of that and the work that he did with our kids. And so it's been really fun because like every studio in our place, photography and design, everybody has used the tech suite. They've been coming up using laser engraving and 3D modeling and printing, and it's been great. So
I think if we can entertain some questions very quickly, and then I think we want to open it up again to kind of have everyone come around, and we can answer more questions as we look at the machine. So does anybody have a question?
So when you're talking about shapeshifter.io and using that like with students and stuff, because it seemed like a pretty simple use process, you needed some sort of scanner to like.
for shapeshifter, no.
No.
No, you start with a template.
Oh,
you just
start with a template.
choose
Okay.
a template out of a list in a menu. And then you begin to like work with that shape, and you can twist it, you can change the taper, you can add patterns to the outside.
And then how does it go from just like the modeling on the computer to actually becoming something real? Like how does that break down?
To the printer?
Yeah.
So, okay, so one thing that we've done a lot of is we've had the kids create lampshades in Shapeshifter. It's kind of cool because you can have these like patterns on the outside of the lamp that are like hearts or circles or squares or whatever. And so when you're done editing your model, then you download it as either an STL or an OBJ file. Mm-hmm. And then you take that into slicing software for whatever printer. Like if you're using the M2, you might be using Simplify 3D. So every printer has slicing software that processes the model and prepares it for printing. And when it literally slices the model, and then it translates layer by layer to printing on the 3D printer. So you might be directly connected to a printer, or you might send it to an SD card or a USB.
Just
Yeah.
plug it in. Okay.
Yeah. Yep. And then you just open it up, and away you go.
Any other questions for Jill and Dave? All right. Yep.
All right.
I was just curious, so what would you say your overall investment was to get from zero to getting something working?
Well,
Oh, that's a good question.
when I can speak to kind of overall investment to the point where we kind of opened up traditional programming in the space from kind of shifting from pilot courses, which we ran pretty rigorously, up to the point where I just shared, we did like kind of the ribbon cutting, which would be now we're running classes day and night and all that good stuff. So remember though, this number is inclusive of purchase of the equipment, renovation of this space, the research and development, so those trips we went on. It actually covered the curriculum development, the pilot courses, so there's staff time and implementation, much material that was purchased so we can sustain this for at least a year or 2 years out. So we have a lot of filaments for the machines and things like that. So it's really under 500,000, but it's a lot. Yeah, I mean it's probably 450,000. I think equipment acquisition was it 100?
Probably close to 100.
I think a little over 100,000 in equipment.
We had 10 3D printers and a laser engraver. So.
And a big piece of that, I mean, when equipment needs direct venting, such as like a laser engraver with direct vent, you really want to do that properly. In our space, As you can see, it's not like a shop classroom, so we can't really, we can't have loud fans running to ventilate, so we had to roof mount these things and do it in that fashion, which I would highly suggest. If I learned anything, it's wonderful to be able to run this equipment and have almost silence in the space to be able to still teach as well and use that for multi-use, because these machines, they can be running again for many, many hours to execute these outcomes. So being sensitive to that is important. It's great to have a ton of equipment, but if the fan's louder than you can talk, that affects the environment, obviously. So.
Wonderful. Thank you so much for
Thank you.
doing this presentation for us.
Oh, thanks for having us. Thank you.
Thank you.
That was excellent.
Great.
So right now, I'd like to turn the floor back over to Greg and Max from Tethon 3D. They're going to be doing some modeling demonstrations, as well as using the Form Lab printer, the resin printer. So feel free to stick around for that. Thanks so much for coming.
It was on mute. Thanks. Okay. Hi, everyone. I'm going to get this printer, the SLA printer, going. If anybody wants to see that happen, feel free to just walk around the room and do whatever you want. It's going to be a little casual, but I am going to get this printer going. So this is a SLA Form Labs printer. SLA is selective laser, so there's a laser that's on the bottom of that machine that's going to shine through the clear glass window and cure UV resin. So this is the porcelain material that we developed at Tethon 3D. It took us quite a while to develop, and it's the first ceramic material for SLA printing. So you want to shake it before you start. Make sure your lid's tight so you don't. But it's pretty simple. It's just like, looks a lot like slip, like you shake slip to make sure you stir it up before every use. It's just a real nice material. I'm probably over shaking it, but I want to make sure it works for this presentation. So these are a consumable tray. They come right out. It's pretty simple. So you just buy these. Each tray is specific to its resin. So like if you were to, this machine can handle multiple materials. It can handle a casting resin as well as a flexible resin as well as a durable plastic resin. So every material that you're using, you want its own dedicated tank. These tanks are consumable. They will wear out eventually. They generally wear out in about 2 bottles of resin. So that's standard with the rest of the Form Labs printers. So you stick this in. You have this on. This is your build plate. Take your resin, just pour it into it. This is a lot like how the Form Lab sets up for their materials. So you see that lovely porcelain coming out. You want to make sure this printer is level. I'm going to be able to get away with it for this print, but once you have it set up in your studio, you really want to make sure it's level and just so that resin sits level. So there's a little fill line that you just pay attention to. To fill it up to, you don't want to go over that line because if you do, resin will overflow over the machine, get down into the internals, and pretty much stop your machine from working. But Form Labs is really, really great about that, and if you do that, they will replace your motor, even with our material. So as long as it's under the 1-year warranty, they'll replace your motors, and I've already done that. So
When it's my turn.
they'll also give you this little magnet when you lose it too. So this printer is pretty, it's pretty simple to use. This magnet's not, it doesn't sit right, so that's, normally you just shut this lid and you don't have to mess with this, but the magnet came out and we're dealing with what we have. There, ready to print. You can see that right there. So with a lot of the other printers, like the filament printers, the FDM printers, they often take a lot of calibration and setup, and like your print is determined how what the infill is, and you have to set all those parameters up, how hot the hot end is, how much air you have going to it. There's a lot of different things. Form Labs is pretty simple. There's not a whole lot of setup. I did most of it already. And so you're not going to really see what I have on my computer as well. I'll show this on my computer over on the main screen, but I'm just going to get this print going. So that's, I'm going to get the print going so that way we can have something to look at the end. So I'm going to put in my flash drive, and I'm just going to print our buffalo, our company logo. This was designed for the SLA material. Feel free to pass it around. Where you see the rough area is 1 coat of glaze, and where you see the shiny area is 2 coats of glaze. So, is that brushed or dipped? Dipped. And I often, to preserve detail, I will thin out the glaze a lot and dip it like 3 to 4 to 5 times depending on how detailed the object. Just the thinner coats of glaze helps preserve the detail in the end. If you just put a really thick coat of glaze, it just kind of covers up things right away.
Have you
Yep, we definitely spraying works. A lot of these objects are super small, so like the sprayer will just knock things over. That's kind of why I go for dipping just off the bat. And like I said in my lecture, I'm really into low effort, high yield. And dipping is faster than spraying 95% of the time. So I will go quicker, but a lot of stuff really works. So, and I'm just getting this printer going, and then I will show you what I did on that computer over there. But, so like I just made a file, I brought the file into the computer, clicked make support, set the support material at about 0.7 millimeters at the point size. You can have multiple objects in the print bed, but for time's sake, I'm just going to probably print 2. And you can move stuff. This software is pretty easy. It's really user-friendly. The first time that you download the software, you can just plug in your printer and it recognizes it, which is amazing. Like if you ever had to set up a 3D printer, it can take days. So we're just going to click print here. What's really fun about these printers is they all have their own serial name. There's no serial number. So this printer is called Efficient Mink, and you can plug in multiple printers and you'll be able to select your printer. And it's easy, already named. Everything's organized for you coming out of the box. So when you start getting multiple printers, it's easy to keep them separated. Our other printer is called Efficient Mink and Peaceful Martin. What's your printer?
Determined pup.
Determined Pup. So it's like, all right. But you remember it. Yeah. So I'm just going to hit, it's going to ask me a couple questions, make sure I have enough resin. Remember to inspect your tank before printing to make sure it's a good tank. And then it says you're using black material, so make sure black material is in there. But with our resin, it works on clear and black. Black I use for a little bit larger of a part. Clear I use for a little bit smaller of a part. It's just the intensity of the laser is more at black. So, so now it's starting to load the file. So on here it should say press this button to start the print. And so now it's going to adjust and self-level the bed as this comes down, and we're good to go. So that's the whole setup of the 3D printer. It's going to take about an hour, 2.5 hours for that to print, so feel free to come back. You're going to see this move down right here. The resin is starting to rise. This is going to start adjusting. Oh, does it say it needs to close the lid? Yes, I thought so.
Yeah, I got it.
Thanks. Oops. This isn't ideal. I should have brought the other one, but. So I wouldn't recommend what I'm about to do, but. So like the UV light exposes the material, so this is all cured through UV light. The UV light interacts with the porcelain and just makes the solid, durable object. Very high detail with the laser, so it's very accurate. We really like working with it. It took us some time to figure it out, but we really hope to see what people are going to do. And if you become a user, please feel free to let me know what you think, what you believe needs to be improved, issues that you're having, because we have a lot of room with what we can do with this material, so we're constantly going to be developing it, making new variations of it and new ways to work with it. So this is basically how you set up the Formlabs printer. I really like it because it is simple. They talked a lot about calibrations and having to learn how to work on these machines. It's definitely true because you will have to replace something on here, but it's far, far, far less than any other 3D printer. Like the powder printers, they're pretty finicky on making them work, but they were really early technology, early 2000s, and this was later 2000s, and they just updated this machine to make a bigger platform, a little bit faster, and some newer features. So next, I kind of want to just show you a pretty simple software program. It's called Mesh Mixer. It's how I've been kind of getting into this. I've been trying to find different things to make, and I've been really enjoying making historic artifacts from this printer because you can really get to see them in different ways. And so, So I went ahead and went to this website called Yeggi, YEGGI.com. It's a really, really great website for a 3D warehouse facility. It's actually like the Google of 3D warehouses. So it searches multiple 3D warehouses and it gives you a wide range of 3D files. So people might be familiar with Thingiverse. This searches Thingiverse, Maker, everything, and like it gives you a wide range of files. And it also searches a lot of museums so you can get historic artifacts. So I went ahead and downloaded a ceramic file that it was once made in ceramics already, and so I downloaded this object because I really wanted to print it out and kind of study it and look at it. And I had the opportunity to go to the British Museum and actually check this out in person. So you can see there on the file, it's pretty detailed. There's a lot of stuff going on in this model, but there's some things that I don't like about it. So it's on a really big, thick base. Like to print that base is going to be extra expensive. So I really want to just get rid of that and then also clean up the file. And then I want to hollow it so I can save some more money and do a couple hulls. So this program is free. Feel free to download it. It's a really great program. So the first thing we want to do is we're going to kind of get into how to use this program. So what I want to do is fix this model and make sure it's all watertight and it's the most solid model possible. Because sometimes whenever you download a 3D scan, there's going to be small holes in it, and that will affect the quality of your print later. So this is just kind of a first step, and we're not going to see a whole lot what we're going to do. So we're going to we're going to make it solid and make sure there's no cracks in it. So we're going to go to Edit, and then we're going to go to Make Solid. So it's going to go through some editing, and then you see all of a sudden like, whoa, it didn't preserve any of this detail. It's all jagged, like what's going on? We don't like that. So we look at the different options that we have, and one is solid type, and it says fast. We don't want fast, we want accurate. So we go to, is it blocky? No, we don't want it blocky, but you might, it could be a cool rendition of this object. Do we want accurate? Yes, but we also want sharp edges to be preserved, so all the edge quality to preserve. So we're going to click that. We're going to go to automatic. We're going to increase the solid accuracy. We'll increase the mesh density just to make sure it's like a really nice, clean thing. Like mesh density means how close the polygons and the little lines that make up the object are and just how many there are. And mesh often increases detail, but also increases the file size. So you don't want to make it so big that your computer can't handle it. So we're just going to go to update. It's going to run its other algorithm. This takes some time depending on your computer, so you generally have to wait for it. But I just want to show you, like, to do this in another program, you're going to be running through multiple steps. Like to do this in Maya could take you several hours. So like it does take some time on the checking for errors part. So we might come up with some errors, we might not. I'm going to plug in my computer real quick. Feel free to ask questions as I go. Like this, it's pretty informal. Does anybody have a Formlabs printer? Nope. No SLA. Does anybody have a 3D printer in general? Nope. So everybody's here just learning about it. Has anybody had any 3D modeling experience? Okay. I'm just trying to see what everybody's ideas are and what they can do. So you can see this came back. It's definitely not as accurate as I want it. So the mesh density should come up a little bit. And the solid accuracy should come up a little bit. And so we got to update that again. I really like Autodesk programs. They're all free for educational purposes. And they're all very, very powerful, and a lot of them will work together, and a lot of them will help you. Like if you start off with a really simple program, some of the things that you learn in the simple program are going to translate as you go into more complex programs. So Autodesk, if you go to the educational website, you can download any of their programs for free, and that includes AutoCAD, that includes Maya, that includes Mudbox, that includes all the, there's just a lot of, there's Fusion 360 and a couple other ones that they have, and all their products work pretty well. There are some better programs, but the fact that they're all free and they all work together, I kind of tend to stick with those programs. This is taking a little bit longer, but that's how it goes. See how the printer's going. The way I work is I'll model, check the printers, go somewhere else, take a phone call, email, go back to the computer. It's a lot of that. You just really got to find your own workflow in this material and in this way. Like there is no correct way right now. We're all trying to figure it out. I call myself a dirty modeler. Like I don't know how to model that well. Like I've kind of been self-taught. There wasn't a whole lot of instructions for when I first started on how to make 3D printed objects, so I was just doing whatever worked. And Max, he's a professionally trained 3D modeler who's gone through the schooling and the education, and he's really quite phenomenal at 3D modeling. And it's just like my approach and his approach are completely different, but yet we still come to the similar conclusion in the way that we work. And that's just the same way with all potters. It's like you might center differently than you, and it's like, but you're still getting that clay centered and you're still pulling the same way. And each way of approaching something will make a different object. So this is taking a little bit. I might just cancel this and we'll see how that goes. I probably just froze my computer. Don't click a whole lot whenever you're doing this stuff, but I might just keep it a little bit low res for it. So I'm gonna double check this is moving. Yep. So while we're waiting on this program, I'm gonna show you Form Labs. So this is So this is Preform. This is the SLA printer software. And this just comes standard. You can download this off the internet. There's a couple different ways you can apply material. So there's a bunch of form settings. So you have the printer model. You have a Form 1 or Form 1 Plus or Form 2. We have a Form 1 Plus. The material, I like to print most of the time in black because it's just standard and it works really well. Clear also works well. Clear can give you a couple different options as well, but we're going to stick in black for today. I'm going to go ahead and load in the ceramic object that I was going to work on. It will print, but I have a couple errors in it, and I don't really like that base, and it's really solid, but just for this demo, I'm going to get this going. So you can do a drag and drop, which is real nice, or you can go to File, Import, and bring in an object just like you would. So you can see here is that ceramic figurine. It has that wide base on there. I wouldn't really recommend doing that, but you can scale the object in here so you don't have to set the size. So we can see it's in millimeters, and you can scale this down in any direction. You can keep it uniform, you can keep it not uniform. When it's too big, you see this message that pops up on the bottom that says models outside the bounding box, and it also goes red. So you have some orientation there. I'll often, whenever I bring in a new model, I'll let the computer orient it for me. So you see the square being rotated, so that means just rotate your object in the specific orientation. And the printer will decide what's the best orientation, and it's often right. So you just click Orient Selected, and it's going to run through its little calculation. And then it's going to put it in what it thinks its best orientation. So it's going to kick it off to the side, keep it like that, and that's what the printer says is best. So I'm going to... Yep, but it's going to be upside down. So this part right here is going to be connected to that build bed. Yep, and it's going to come up first. So the last thing will be printed is right here. So now we'll add supports. So somebody had this question about how do you add these supports. You have some control over how it works, like the density. So that means how many points or how close they are together. So the more dense it is, the higher that number, the closer the points are together. The less the number is, the farther the points are apart. Their normal point size is 0.6. That's kind of like their standard. We go a little bit higher than that just because the ceramic material is a little bit heavier and it can pull off those points. So we'll go to 0.75. No, you have to change it every time. And then internal supports, so if you would have a hollow object, that's going to fill in the internal of it and help support it. Some objects you have to do that, some objects you don't. And then you just you can go to advanced settings and you have some more options, and some of these options you'll have to do, but I honestly have never had to go into the advanced options to make a model work. So, but they just give you some more options. So you just go to generate all. So far, all this is pretty simple. Like, these are just typical things, and you only have to make this file once. Once you make this file, you can continually print with it with the support structure. So a lot of times I will print it first, and then I'll realize, okay, my support structure wasn't quite right. It took off one piece of detail that I really liked, so I'll go into my saved file, change some of the supports, and then go and print again. So this will allow me to edit the supports as well. So that one's going. Oh, there it is. Okay, so this one finished. We're just going to accept it. I really wouldn't. We'd have to let it generate all the files. Oh, it came back. So now we're going to trim it. So we're going to take off that bad base. And that is plain cut. So like, you can kind of just go through and read these things. So like, what are you going to do to the object? Are you going to mesh mix it? No. Am I going to select it? No, I don't really need to select it. Do I need to sculpt on it? No. Am I going to put a stamp on it? No. But am I going to edit it? Yes. I want to edit this file. So you just go into edit, and then you just look through the different things. Am I going to mirror it? No. Am I going to duplicate it? No. But I'm going to plain cut it. So you have this. And you can see these arrows, and the solid object is what's going to be kept, and the translucent object is what's going to be discarded. So we're going to move this down to about right there, and then we're just going to go to cut discard half. So like the part that is cut, it's going to discard, and then the fill type is going to remesh fill. So that's going to make sure it's capped at the bottom. And then you just go to accept, and that just cut off the bottom. And then I always go to close cracks just to make sure that that bottom filled properly. And then we go to hollow. So for all 3D printing pieces, even if you send it to us as a service, this is a great way to save some money on any 3D print. It's also a great way to save material if you are printing yourself. So you can see the outside ghost image is going to be the outside, and then the gray part is the inside hollow. So we're going to increase this to 4 millimeters to make sure we just have a really thick base, give it enough support. You could, as time, you could probably start bringing this down to learn exactly what you need if you were going to replicate this object a lot. And then we also want to put holes in it so we can have the resin come out after we're done printing. So we want 2 holes, because one hole for air to travel through and the other so the resin can come out. So it does cleaning. One hole, it'll be really hard to get the resin out. And then you can also choose the hole diameter. So we'll go to generate hole, puts my holes in exactly where I want them. Sometimes it doesn't do that, and you just grab the red dot and you can move that hole around. So it's pretty good. It's exactly where I want them. I want them on the base so that way it's hidden and all the resin can drain out after it's done printing. So now you go to accept. And we'll go to view real quick and just turn off the grid and turn off the printer bed. And so now you can see there's 2 holes on the bottom of the print, And this object is now ready to send to the Formlabs printer. So we just downloaded it off the internet, made a few corrections to the file to make it specified for that printer or any type of 3D printer. These are all good things to use on any type of 3D printer, but it just makes sure it's a nice object and we took care of some of the features that we wanted. And this program is not that complicated. It's free to download, and the user interface is enough to where it's like there's not 500 options, so you can kind of go through it systematically and learn what you want to do. So we'll go back to real quick preform to show the printed structure on this object. So this is the fixture that's going to support the material. You can see this is going to be 1,777.73 milliliters, so that's almost a liter, so that's quite a large object for this Formlabs printer. This might not be the best orientation, or you might have to add more support structure, because you can see there's slightly some red right here, and whenever you see red, that means it's unsupported, and we might have to put some more support material there. So we're going to go to the fixture again. We'll go to Edit All. It took away all the supports, and you can kind of see that there's a bunch of blue dots now everywhere, and those blue dots correlate to the fixture. And so you want to make sure that our point size is correct, so we're going up to about 0.6, and then you can just start clicking and adding these points on. But let's say we don't want a point on, like, let's say like right here. Let's blow this up so like right here there's a point, and I don't know if I necessarily want there, so you just hover over it, click it, and it takes it off. So once you kind of edit all your support structure, make it where you want it, from here it's pretty much ready to go to the printer. So once you make all your support structure, you can just click print. I don't have it hooked up to my printer right now, but that's where you would just go to send the printer, and then it starts printing. So this is a lot. There's a lot you can do with these two programs to make a printable file and get them going. Formlabs printer software is really easy to use as far as printer software goes. It's pretty self-explanatory. It's more image-based, so you kind of have to memorize the symbols. But once you get past that, knowing what those symbols mean, then it's pretty easy to operate.
After you're done printing it, you have to physically remove support.
Yep, and a lot of those support, thanks for bringing that up, a lot of those support materials can be easily broken off by hand. Like you can almost just twist the object and it's going to pry away from all those supports because the weakest connection is at that support material. But for delicate objects like these hands, I'll often make sure I snip way back so it's not taking away, and then after I got all the support off, I'll go and snip closer and then file down to make sure I'm not damaging my most delicate parts. Does anybody have any questions, or would you like me to explain anything more? Max is about to come up and talk more about Maya, which is a lot more an intensive program, but what you can do, you can start from scratch in objects, and it's a very, you can do anything in this program. You can make a Pixar film if you wanted to. So feel free to come up and ask me questions too.
Yeah, I wasn't able to attend your earlier lecture. It comes out fully ready to fire? Is that...
Yep. So the material that's being printed right now is a UV-based curable resin. So a laser, a UV light laser, is shining on the resin, and it makes it a solid ceramic composite. From there, you can take that solid ceramic composite, put it in a kiln, fire it just like traditional ceramics, and then glaze it as well.
Are there certain firing points?
I bisque to cone 3 at the moment because I like to bisque around 2,000 degrees for this material. You can bisque lower, but it's a little bit weaker of an object, but sometimes you want that to get the coefficient of the expansion of the glaze to fit with your body right. So I do that, but there's really no, like you can fire it much faster than traditional ceramics because of its porosity. Sorry? Bisque. Yep, in the SLA do cone 3. You could probably bisque it to cone 6 just fine. I just started going to cone 3 just because I felt like I wasn't quite sure. There's still a lot of experimentation to be done on this material to figure out the best firing process. It took me a couple years to decide on cone 6 before I decided on cone 6.
Does it release any different chemicals?
Yep, so there is some burn off. The resin does burn off, so we highly recommend a ventilated kiln. But that really just kind of takes care of it. So as long as your kiln is ventilated, you should be fine. And
Does it affect other objects?
yes, maybe. Depends on your glaze, your surrounding objects. It does not affect as far as like bisqueware, like it doesn't do anything like that. All the carbon burns off early enough in the kiln so that way it doesn't affect your piece. But it may or may not have some trace elements on a glaze if it absorbs some of the materials, But I only say that because there's a million glazes and I can't guarantee things.
So you don't need the slicing software?
This is the Formlabs is the slicing software. And so that's what's kind of nice about Formlabs. It kind of takes care of all the slicing and telling you the different parameters that you just kind of plug and play. It's very much a plug and play system. You can change the layer height of the Formlab printer so you can go, so this was an 8-hour print right at the fastest layer. So this is a 0.1 layer, but if you bring it down to 0.25, it moves up to a 25-hour print. So the 25-hour print is going to be an incredibly high detail. You won't see any print lines. It's going to be practically a uniform object, but it's going to take you 25 hours to print. So it's just one of those things.
How big is that?
Let's see. So I just rotated it just a little bit to remove the supports. This size is 112.32 millimeters, so that's 11.2 centimeters, which is like 2.54, so like 5 inches. 4 inches. Thanks. Yeah, so it's about 4.5 inches. But our material shrinks 17% by cone 6, so it's a kind of high shrink rate, but every day that's being improved. So I'm going to be hanging out over there. Feel free to ask questions. Max is going to come up and start modeling and seeing what we can get from there. It's a prairie dog. That was the last thing I was modeling. Huh?
I have the cookies yours over there.
Oh, thanks.
So if you want food.
So give it up for Max. Yay.
Yay. All right. It's been a while since I've used a Mac computer. Usually on my PC. I'm a PC man. And I'm a pen and tablet man now. It's been a while since I've modeled with a mouse. So this will be interesting. All right. Yeah, it works. All right, so what we're going to do here is run you through a basic coffee mug. I'm not going to go into complete detail for each program. You're just going to see how simple it can be once you kind of get a handle on how to make the objects or how to work with the program. All right, we have to hold the Apple key instead of the Alt key. Got it. So coffee mug, let's go with basic shape. There's many ways in Maya to get around to certain objects. Create polygon primitives cylinder. We can create the cylinder from here. I can hold spacebar, go to mesh, or no, it's create polygon primitives cylinder. Tons of ways. I could even have held shift right click, create polygon cylinder. They have a lot of ways for a lot of workflows that you want to use. So, I mean, we've almost got a coffee mug. We're almost done, right? So let's give it an inside edge. So I went to the right click, and we can go into the different modes to mess around with the different parts of the object. Each little point is a vert. Ooh, I got louder. Each line is an edge, and each connection of lines is a face. So we want to go into face mode, grab all these, make sure we don't have any ones selected behind it. Oop. We want to control select. This is Autodesk Maya, and as you can see up top, it's an educational version, so you don't have to have an educational Gmail or email or anything. You can just say you're a student of life, get it for free, work with it, save it. It's pretty useful. This is what I use for everything. This is my background is in digital arts for video games and film and whatnot, and it transferred over pretty well to printing. So I have to find these tools. I know how to do what I want to do quickly with a few clicks, but we want to go to Edit Mesh, and there should be an extrude option right here. And what that'll do is give me some more information to work with. Oop, R. Okay, hold on. So there we go. We got that little bit of information. It gave me a little more polys to work with. And we will repeat that process by pressing G, or Edit Mesh Extrude, and I'm going to drop it down. Now we really got a coffee mug. So there we go, press buttons. As you can see here, I smooth the object. That's by pressing 3. It gives me kind of a preview of what it would look like if it's smoothed. So I want to go back to this. So when I press 3, you saw it rounded out a little too much. So we want to keep that bottom flat against the ground. So another option to go to, we want to Edit Mesh, Insert Edge Loop Tool. So this will give me another ring of information to work with right here. And when I press 3 again, with double the amount there, it's held the shape a lot better. So okay, we've got that. Now, so if you were at our talk earlier, anything with a flat bottom, we want a concave bottom, right? Don't want to break the rules myself, so we want to select these faces, make sure nothing else is selected. And what I do to make sure that doesn't happen is we go to Shading, Backface Culling, and Shading, X-Ray Active Components. Now I can see through the object, see if I have anything selected I don't want selected. It makes it a lot easier to work with. So I use a lot of tools over and over again to get what you want. So we want to, again, extrude face. See how I just did this here? There's another way of getting to it. Shift right click, hold down extrude face. Again, this is something you won't need to know right away. And I don't know why it's throwing up the pivot right here. But we can just bring that down here. So now we've got the foot a little bit better defined, so that holds in place. And we want to repeat it because we want to make it concave. So G to repeat, scale it in, pull it up. Almost there. We gotta, well, we're pretty much there. That foot's a little not solid enough for us, but all we have to do is, again, insert edge loop, Edit Mesh, insert edge loop. And how you do this is when you have two edges right next to each other, it holds information a little bit better. So it doesn't, when it smooths it, it sees these two close edges and it wants to keep that a little sharper. So, all right, coffee mug bottom. Pretty simple. So this top's a little too sharp for your lip. You don't want to keep it that way. We'll go back into this and we will Edit Mesh, insert edge loop. And you'll see I'll use these same tools over and over and over again. And then I'll drop actually a bunch in here to kind of hold the shape in. Because I know what I'm doing at this point. I know what these things are going to do. 3, a little sharp, but we can work with that. And you can even delete edges in one go. Double click, right click, go to edge. Sorry, I'm doing this a little quickly. And I grab a whole ring like it did around there. And so we got a coffee mug basically there. But it's a coffee mug without a handle. So let's go and grab some areas here. We want to create something that we can pull out to make into the handle. So we are going to go back to inserting edge loops to give us information. Insert edge loop right here. Let's say that's the top of where we want the handle come out. And this is the bottom of where we want the handle to come out. And we'll put it right here, right here. So let's see, let's make sure we grab it from the top. Oh, that's going to give us some issues. Rotate it. 7.5 degrees. Another thing you can do is look at it in every single view. You can look at it side, front, top, bottom. So what I'm trying to do is get this little polygon here flat, so when I pull it out, it pulls it straight out of the object, so I'm not pulling it out at weird angles. So let's see, that's 8. Nope, not 8, 9. There we go. 9 is the perfect number. So, and then I'm going to modify freeze transforms, and that gets everything back to 0. So when you select these faces right here to pull out, I'm going to extrude like I did before. Edit mesh, extrude. So we got the beginnings of our handle. And then it's all about manipulating the verts in one way or another. I mean, when I grab an edge, it's moving 2 verts. When I grab a face right here, it's moving 4 verts at a time. And I can scale the face up. I can rotate the face so it's doing weird things. So I actually want to delete these faces. I don't like them right now. And I want to connect these. So let's make it so I can. We're going to grab these edges, pull them back. And now what we want to do is grab here and here. And let's see if I have to go the slow way to it. Mesh bridge. So here, let's just grab this. We're going to extrude again. Extrude edge. Edit mesh. Extrude. Grab it and pull. Simple as that. So we're about got it. So now all I have to do is I have to go to these vert information and snap them. I hold V when I do this, and it snaps it right to where it is. So even when I do this, and even though it looks like they're perfectly connected and whatnot, there's still 2 verts there. There's an infinitesimally small opening in here between it. So you have to remember to close your edges in this program. That would have made it not print worthy. So that's something you have to keep in mind. So I'd never be able to print this object as long as I had never merged those. So edit mesh, merge. So let's see if we can display, heads up display, poly count. See those little numbers that popped up? I have 4 verts selected, and there's 4 verts there. Before I did that, there's 8. I don't know how well you can see that on that screen. So Shift C, I'm redoing, merge verts. So technically, you've got a 3D printable object, coffee mug with a handle, really ugly handle. But we can even edit that by continuing with insert edge loop. And you also see insert edge loop, extrude is the main tools I use for everything. And you can pretty much create everything that way, as well as manipulating everything that you work with. And it's a coffee mug. It's going to warp in the kiln, so you want to kind of pull it up here so when it sinks down, it has a little better view for it. All right. So I know I'm going a little quickly through it. I just kind of wanted to show the basics of what you can do. You can even go so far as, let's work with this model here. We're going to mesh, smooth mesh, and we're going to, let's smooth it a couple times. Yeah. We can even go in and sculpt geometry tools. So see, I've got this brush here. You have to learn how to manipulate the brushes and manipulate the tools, but you eventually can sculpt like you would in other programs. So that's doing that. 0.05, enter. So see how I'm doing there? Just pushing it through the object. It has a really strong brush right now, so I got to drop that down. Maximum displacement, drop that down. There we go. So I don't know if you can see that too well, but I am carving into the object. We can mesh, smooth mesh again, and then we can go back to sculpt geometry and then relax. So same here. So radius. We're working extremely small, so 0.1, enter. So that was a little too angular for us, and we can do stuff like this. And obviously, I'm not making a beautiful cup right now, but that's not the intent of the object we're working with. So, but in reality, this is printable. You could print this funky looking mug if you wanted to. Is there anything I can answer for anybody up here? I pretty much went over the basics of the program. I use a little Intuos tablet. I do sculpting in Mudbox that works with Maya, and you can send it Maya to Mudbox. There's even a button. I don't know if it's this version of Maya, but the one I work with. It's a trackpad. So it's. I also have a Cintiq, which has a little screen, a portable one, so you can draw directly. When you're drawing on it, it happens where your pen's at. So it's like you have a piece of paper that you can press undo on. Yeah, there's some bonus tools in Maya that you can use. It's a plugin download, but if you download that, you can change all the verts or place on all the verts a small vase on the entire object, or randomly. You can select random and where you want it, or wherever your face is. So you can calculate to a certain degree. You can also draw curves on it if you learn how to work with that, and you can extrude or duplicate along curves, so you can have it like spiral down the cup if that's how you wanted it to work. So there's a lot of options to get a lot of things done. Unfortunately, this version of Maya, the tools aren't downloaded yet. So, but yeah, there's a plugin for everything. Yeah.
Do you have to re-topologize when going from Mudbox to Maya?
No, you don't have to, but Maya doesn't like a lot of them, so you might want to drop the polys so it doesn't slow down your machine. And for 3D printing, a lot of novice mistake is more polys is better, but two objects with one has way less polys, as long as the polys are used well, can get the same detail and you won't notice a difference visually. So I'll get clients in and I'll have 12 million polygons for a basic mug with no detail on it, so I'll drop it down to 10,000 for the printer's sake and the computer, so it takes less time to load, and that isn't much effort on my end to do, and I don't have to wait as long. So, but yeah, I guess you would want to because Maya is more for general shaping. You don't want to sculpt so much. Like the sculpting I'm doing in here is only because I don't have Mudbox on this computer. Otherwise, I would just have shot it straight over there. And you can have stencils. You can use a 2D image to stencil onto the object, flowers or daggers, I don't know, whatever you want. It's kind of limitless of what you can do with the thing. Mudbox. Mudbox is also Autodesk, and in the newest, if you download the newest version, there's Maya to Mudbox button, and then it just shoots your thing over there so you can start sculpting. And when you get done sculpting it there and retopologize it, Mudbox to Maya button. Another good sculpting program, they were talking about Sculptress in the last talk, but that's from ZBrush, and that's the free version. But ZBrush is an amazing sculpting program. You can do so much with it. It's almost limitless on what you can do. You have to export the thing and bring it in. I mean, as long as you can export it as a file Maya can read, then it works. And there are plugins out there that it does the same thing, where it will be like, okay, go straight to your Maya file, and just have to learn how to hook that up. So, we got any other questions? It looks like it's it. So, thank you for watching my little ugly mug demo. Thanks.